What is this? Select, PreCalc, poke, save. Okay. So, I don't remember. One of the classes got through all of 3 and... No. One of the classes got through 4, the other one didn't. Did we do 4?
We did 4A and B.
Oh, okay. So you got 4A and B done?
Yeah.
All right, perfect. Hey, get back here. Okay, we'll start with... Oh, I remember talking about dividing 15 by things. We did that one, right? Okay. So let's just varm up. Use a graph to graph thing, tell the thing, to describe how the graph are related. Write the equation for, identify the parent. There we go. Okay. For 3, I'm going to put a quadratic up here. And you need to tell me what the transformations were. So 5, 12, and same. Okay. There we go. So this is 3 on that thumbs slide. I'm making that graph. There is a vertex at -3, -3. There are integer points at -1, -2, and 1, 1. Can you write what transformations happened? How did I get here from plain old x squared? I'm betting you'll be fine with the translations, up, down, right, left. But can you figure out the dilation? Y'all too quiet again. Talk. What do you think? What's your thought process? Okay.
Figure out how to dilate. 2. 9 and 2.
Just the transformations, but if you know the transformations, the equation should be fairly easy, which is actually the next example, if I remember right. I got about 5 slinkies over there. I recommend not having the slinky in class because the slinky is loud. Slink, 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 slink. We do have 2 plastic ones, yes. Go for it. See, there's a difference between I'm fidgeting with something to regulate my nervous system and allow my body to take care of itself so that my brain can work on things. Versus like the freshmen who had all the fidgets taken away from them, I'm just here to play with toys. So, we stumped on the dilation. It is 1/4. How did we get that? Okay, you compare a dilation is what it should have done compared to what it did do. It did this, but it should have done that. Percent increase or decrease, right? If I say your salary this year will be $40,000 a year, and last year it was $42,000. Well, I would do 40 divided by 42, and I would get the percentage of my previous salary. I would also have that as a dilation, as a scale factor. So we know that there's a vertical translation down 3, there's a horizontal translation left 3, and then from my vertex, I go over 2. Normally, I would be going 4 up. I went up 1. So that's my dilation. Okay? What did it do over what should it have done? Okay? Same thing goes for, there's another integer point right here. Well, this is over 1, 2, 3, 4. It should have gone up 16, but instead it went up 4. 4 over 16. Okay? And that works for any function. If I have a logarithm and it should have gone up 1 over 3, but it went up 1 over 6. I know there is a horizontal stretch by 2, so I put a 1/2 in the b spot, the reciprocal. Okay, just getting us warmed back up. So, if you can identify transformations, if you can graph based on transformations, or write an equation based on the graph, then the last few things to do are put it together with, we did piecewise functions before, but they were nice and easy. They were little things like a line over here and a line over there. Now, the piecewise function includes a quadratic, a constant, and a cubic, all in different areas. Now, most of the time, I don't know about you, I got a hard time graphing things without starting at a specific point. Like, if I'm going to graph a quadratic, I want to start at its vertex, because my perfect square steps go from there. If I'm graphing a cubic, I want to know where the inflection point is and go from there. If I'm graphing a line, I want to know where the y-intercept is and start from there. You always start from a specific point. Well, what happens if that point has nothing to do with the actual domain area that the graph is supposed to be in? Do you just stare at a spot and say, okay, from here, but I won't write it? You can do that. Some kids can do that. Another way to do this would be to very lightly just do all 3 graphs and then erase the parts that don't matter. Never do math in pen. Unless it's erasable pens. Who's got the friction pens? Like, there was the old erasable pens that sucked. It was like a ballpoint pen, and it never erased very well. And now they got the friction ones that are heat-based ink. So you just rub the eraser tip on there, and it just kind of invisible inks away. It's great. Really good for lefties. 3x squared. Where's my vertex? 0, 0. And from there, I'll use my perfect square steps, headed north, but 3 times as tall. So over 1, up, not 1, 3. Over 2, up, not 4, 12. Okay. So that is what the graph looks like, but I only care about it from here to here. When x is less than -1. So I'll erase almost everything. I'll go to where x is -1, and I'll get rid of this stuff. What else do I need to change? When x is less than -1 means my final portion of that graph has to go open circle to the wild blue yonder. All right. Next part says I'm going to have y equals -1. So straight across, just constant function. But I only care about it from -1, close circle, to 4, open circle. And I erase the other stuff. Okay? Now, if you don't want to make the entire graph and erase, that's fine. Just make the part that matters. I'm just saying you have choices. Sometimes you have to do the whole thing just so you can tell what's going on and then erase. Other times, you're able to just draw the part of the graph that matters. Contestant 3 is a cubic. The cubic is inflection point, right 5, up 2. From there, cube steps. Left 1, up 1. Left, right 2, up 8. Left 1, down 1. Left 2, down 8. So it's 6, 7, 8. Okay, so that's where the cubic is. Where do I care about it? Only there. So I'll put a closed circle at x is 4, follow the yellow brick road, and then I'll go back and erase the part that I don't care about. And that is my graph. Okay? So a piecewise function, expect that on a quiz, because a piecewise function is a really good way to assess if you know multiple types of graphs on one graph. Okay? So again, look at what you have down here. Linear, cubic, reciprocal, quadratic, constant, absolute value. Literally 6 different functions. This asks, do you know how to graph algebra 2? Okay? So whether you're only graphing the part that matters because you're good, or you graph all 3 and then you have to erase parts that don't matter. Whatever your jam is, do what works for you. I just said 2 ways. Maybe there's a different way that I'm not even thinking of. Go ahead and say it. Okay? Most of the tricks in our tool bag come from working with students. So, 5A and B, I'm just going to have A up here so that I can make big. I don't get it, y'all. I don't know why I have to tell you to talk. I want you to talk. Second hour, nice and blabby. Okay. Then caffeinate like I do. It's a perfect excuse for not sleeping. Where are you, Eldraine? Okay. So I graph all three. Like, well, crap, that's a lot of stuff. But you got to think, where does it matter? On the line. I only care about that where. X is less than 0. So from here back, get rid of the rest of the line. Where do I care about the cubic? Open circle 0 because it does not equal. Closed at 2. Don't care about the rest of the cubic. And I only care about the reciprocal function after 2. So I go to x is 2, open circle, get rid of the rest of it. Okay? Now, I don't know about you, but I could see it being tough just trying to do that. Okay? Now, they're all kind of clustered around the middle in between plus or minus 2. So be a little bit easier. What happens if this disjointed spot happens back at -6? It's going to get funky, and it's going to be real hard to graph it. Funky, right? Oh,
Yeah.
you have a asymptote at 0. You have an asymptote at 0. Take 2 divided by numbers. So away from 0, 0, I go right 1. 2 divided by 1 is 2. 2 divided by 2 is 1. Well, yeah, 2 divided by negative 1 is negative 2. 2 divided by negative 2 is negative 1. Okay. So, I want to know who's brave to try the Eggo ones. There are Eggo Pop-Tarts. We had Fruit Loop last time, and what I heard is the first one, it's not bad. Second one, you regret your life. So, let's see what happens. Did we get B done? Come on now. I said do A and B. I'll only leave A up there so I can make it big.
That looks like somebody painted it. It's got in there.
Oh, try it.
It's just yellow frosting to make it look like a waffle. Well, yeah, it's Pop-Tarts. It's not real food. It's just empty carbs.
You gotta get further flavor. It tastes like frost. You gotta get further.
Got Carter back here like a wine snob, like you got to get the right aroma, the right like cup on it.
That would taste a little bit like frozen waffles.
That's the flavor. So win.
There's no meat.
I hope that everyone who's turning around watching Carter eat Pop-Tarts is done with this graph.
Good thing.
What flavor could you possibly get?
It's not
Eggo Pop-Tarts?
A little bit of maple, a little bit of waffle.
You think they just compressed an Eggo into artificial taste?
I mean, you'd have kind of the buttermilk batter and then a little bit of maple syrup. And then let's be honest, a whole lot of sugar in the frosting.
You make me angry, Jack?
I have a picture out.
Looks like most are done or finishing the last leg of it.
So when there's a negative on the inside, do you reflect it over the x-axis? Is that just when it's on the outside?
Could you rearrange what's in the absolute value to look like B parenthesis x minus h?
Yeah. So if we just take negative 4 by okay. So
When in doubt, you can always graph by table. Like if you're stuck, no joke, put that into y1 and just look at the table, plot points. Okay.
because it's like that 4 plus
It's negative. And then it's absolute value. Wait, I just
it's like the
yeah.
So the last one I did, I put all of the graphs up there and then erased. It was kind of a big snarl, right? It was just a mess of lines and curves. So maybe it's a better idea, maybe a note to write to yourself, to do one at a time. Graph the first part, erase the parts that don't matter. Graph the second part, erase the parts that don't matter. Graph the third part, erase the parts that don't matter. Okay? So this graph, but I only care about it before -5. So I go to -5 with an open circle. Okay. When x is less than -5, open circle to the left. Get rid of the stuff that doesn't matter. And do it again. Y equals 7. But I only care about that graph from 5 over to 2, both with closed circles, because it equals. Then get rid of the part that doesn't matter. This one. Do you agree that it's also that? We talked about when I mess around with the negative in the B spot yesterday. Is this supposed to be left 4 or right 4? You have to separate B from x minus h. And that whole back table just missed that. Man, that'd suck if we put that on your test. Okay.
How is the negative being distributed to the full?
If I divide a negative from here, I have to divide a negative from here.
So if it was
Right?
outside, you wouldn't change anything?
Correct, because we don't distribute into absolute value land. Which means you also can't factor out of absolute value land. So, all right, now, I say you can't distribute into or factor out of absolute value. You can with linear absolute value objects. The reason that I've told kids that from Algebra 1 on up is because you can't as soon as it's nonlinear inside the absolute value, which we get today. Okay? It's one of those things where if you know what's coming down the pipeline, it's better to just know this rule beforehand. So, what does this do? What spot is it in? A, B, H, or K? Go back and look at your Holy Grail. It's grouped in with X. B. B does what when it's negative? Horizontal reflection. What happens when I reflect this horizontally? It's the exact same thing because it has an axis of symmetry. So this actually doesn't do anything. I just go right 4. Now, let's say you don't know transformations. You just see something that doesn't look right. There's nothing wrong with coming back here and saying alpha abs of 4 minus x and going to your table, put it back here. There's nothing wrong with going back here and then plotting by points. Okay? Nothing wrong with that. Now, I don't want that entire blue V. I only care about that blue V from 2 onward. And there would be my graph. So, are we okay with the parts? Like when I erase it, when I open circle, close circle. We're probably sketchy on some of the functions themselves. Okay? That's just something we need practice with. Okay? All of it was algebra 1 and 2. It's expected by now, if you're up in PreCalc, you know how to do them. If you don't know how to do them, it's up to you to get some practice and ask questions. Okay. Do I got any more of those? Let's go forward a few slides and practice that again then. It was forward a couple of slides. Page 26. We'll go back and do the other stuff. But let's try that again. Now, 1 is a constant, 1 is linear, no big deal. Can you do it with a step function? They're not difficult, they're just tedious. All three graphs in the same spot. I only care about green, less than or equal to -3. So back there. The rest of green goes bye-bye. I only care about purple from -2 to 2. -2 open to 2 closed. I don't care about the rest of purple. I only care about the step function from 4 to 6. 1, 2, 3, 4. I don't care about the rest of blue. So 1, 2, 3, 4. Now hold on. Okay, this graph ain't right. This is like a 4 out of 5. Almost there. What's missing?
Would you put the dot on top?
Because it's from 4 to 6 inclusive. Because it equals 6. Right now I have an open circle at 6. I would have to go right above that to include 6. Ah, snaky. Did I count right? 4 to 5, 5. Oh, I went to 7. Oop. So, you got to be able to graph functions if you need practice with the functions. I don't remember which classes I said this in. I said it to someone yesterday. The homework assignments, it's not just do these problems, that's it. The idea behind the homework assignment and keeping it small is independent practice so you can confirm that you know how to do it on your own. Well, what happens when you do number 28 and it didn't go very well? You know there's probably like 4 problems right next to it that are similar. Maybe try one of those too. It's not just do the thing to get it done. It's do the thing to confirm you know how to do it. Okay, that's why the assignments are so small. If you get it, if you're confident, okay. If you're not, that's when you ask questions and try again. All right, so now we need to back up to example 6. The beginning of the semester, we're reviewing quadratics. I talk about complete the square. And everyone's like, yeah, I remember doing that in Algebra 1. Then I forgot it. I remember doing that in Algebra 2. Then I forgot it. Okay, we reviewed it in PreCalc. It was on your first quiz. Do you remember how to do it? You just wait for chapter 7 when you got to do it at least twice in a problem. Okay. Because I'm going to have to complete the square here to turn this into transformation form. This is a Algebra 1 skill. We showed you back then. We showed you again in Algebra 2. You forgot it. Here it is again. The path, a 60-yard punt, can be modeled by this particular equation. G of x is vertical distance, height, and x is a horizontal distance. So, if you know how that works, if you follow the foosball, you got your field, got midfield, got your end zones, and then within there, I've got 1, 2, 3, 4. 1, 2, 3, 4. Okay. They're saying that stick figure Steve is going to be at the kicking team's 20-yard line. So he's back here. He's going to kick the ball. Boop. And the height of the ball and the horizontal distance are going to be my g of x and x. Better if you see it drawn out, right? Okay. Describe the transformations. So basically, blah, 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 blah. Here's an equation. Put it in transformation form. Okay? So do you remember how to complete the square on a quadratic? If I have g of x is negative 1/15 x squared plus 4x plus 1. Okay? X stuff on one side, not X stuff on the other side. So g of x minus 1 is, I also have this negative 1/15 in the way. Eliminate the Canadians. Divide everything by 8. If I divide by a negative 1/15, multiply by a negative 15 over 1, right? So everything by negative 15. I'm just going to leave, well, yeah. Getting negative 15 g of x plus 15 is x squared minus 60x. Complete the square. What is the magic number that I add to both sides? Okay. Currently b is negative 60. Half of that. Squared. 9 hondo. Half of negative 60 is negative 30. That's b over 2. b over 2 squared, 30 by 30. So I add 900 to both sides. So now I have negative 15 g of x plus 915 is, now I can write this as a binomial squared. It's always x plus b over 2, so minus 30, the quantity squared. Now go and get g of x by itself, back where it's supposed to be. Subtract 915. Divide everything by a negative 15. Getting g of x is a negative 1/15 x minus 30 squared plus 61. Okay. So now that I'm there, I have my function in transformation form instead of standard form. You see why you probably forgot it from Algebra 1 and 2? It's got a lot of moving parts. Fractions, big numbers. Most kids will just give up, just not do it. Describe the transformations. I got a negative out front in the A spot. What's it do? Okay, so I have reflection in x-axis. That negative is attached to a 1/15, also in the A spot. Now you can say a dilation to cover all bases, or it would be a compression because it's less than 1. I'm cool with either one. I've got a minus 30 grouped in with x. A, B, H, or K? H. It's in my horizontal translation spot, which is bass-ackwards land. Okay, that's a horizontal translation right 30. Which should make sense on the football field. If I'm at the 20-yard line, I'm 30 yards away from the end of the field because the end zone itself is 10 yards. And plus 61. Vertical translation. Up 61. Which means he kicked it 61 yards in the air. Now, that was one way to do complete the square. That's by moving things off of one side. I need to ask if you've seen this other method before. I hope so. Well, I know you've seen it. It's just whether you remember it. The other way to do this is to factor negative 1/15 out of x squared and 4x, and then shove that 1 off to the side. To say, this is going to be the trinomial part. The 1 isn't a part of this conversation. And then b over 2 squared is plus 900. But I've got to remember it's in the parentheses. So I didn't really add 900, negative 1/15 of 900. I just subtracted 60. So I need to add 60 to balance it out. Getting all the way to the end zone in only 2 steps. Okay, that is the preferred way to do it. Some kids, the idea of only taking this out, shoving this one off to the side, and kind of working in the middle of the equation, some of us are, I just don't like that. It's not my jam. I would rather do more work, but it makes sense to me. Okay? Plus 60. Okay? So, I get here. This is all review of quadratics. And then I make you really mad by saying, zoom fit. You're not going to show me the vertex, are you? All right. I was just seeing if it would work. My window goes from 0 to 120 yards, is the football field. What's the highest that I think this guy can kick it in the air? I don't know. If you can go 100 yards in the air, I'd say you're pretty boss. And then go look at the table. Look at the graph. Come on, Frank. Calculate my maximum. Y'all. Oh, plus 30. There's more than one way to get here.
How do you find the transformations though? Or would you?
Because once you know the vertex, you can put it in vertex form. And A is always the same whether it's in standard or vertex form. If I know that the vertex is at 30, 61, then I can say minus H plus K. Vertex form of a quadratic. Okay? And A is the same whether you're in standard or transformation form. So, I just showed you what? 3 different ways? 4? 4 ways to get these transformations. You pick and choose what you want. This had more ways to do it because it was a quadratic. This one's just a radical. That's no big deal. What happens if it's just a line, if it's just a cubic? Okay. Every function is going to have its own methods. Part B, suppose the punt was from the kicking team's 30-yard line. So if that yellow equation right now is kicking from the 20-yard line, because it's 30 yards away from the end of the field, what's going to change to be at the 30-yard line? The H is going to change 10 more yards downfield. No, 10 yards down that way, not up. That's it. Graph both functions on the calculator screen. So again, I've got this. Okay, round 2 could be -1 15th, 15th, not 5th, x minus 40, the quantity squared, plus 61. Graph of phi, 10 yards downfield. Okay. So, I wanted to go through that one together because it's a quadratic, and I bet if I left you to your own devices, would have been a little iffy. This is just a radical. This is just straight up square root. Can you answer those 3 questions? What are the transformations now? What if this changed? Graph them both, see if it makes sense. Okay, don't overthink this one. I of x is square root of, if you want to call it 1/11th times x, right? X over 11 is 1/11th of x, which puts 1/11th in which spot? A, B, H, or K? B. That's in the radical, not outside of the radical. It's in the function grouping with x. So if this is in the B spot, that means, well, go back to your Holy Grail. 1/11th is less than 1. When B is less than 1, what does it do? Remember, B is bass-backwards. This is a horizontal stretch by the reciprocal by 11. B and H are bass-backwards. If it says 1/11th, imagine you're working your job this summer and all of a sudden your parents say you can have 1/11th of your income. The rest goes into savings. Doesn't it take you 11 times longer to get to whatever your goal is? Okay. So that's part A. B, the resistance of the lamp is 15 ohms. Look at the original. Where am I sticking 15? Where the 11 is. So that's just I of x is now square root of x over 15. And graph the resistance of both. You're going to have one of them is really stretched, and the other one is really, really stretched. That's it. So, it all comes back to that Holy Grail. Y'all remember where it is in your notes? Okay. We put it right there. You should have had that beat into your skull throughout Algebra 2. This is just trying to refresh your memory. And I said the first couple sections of PreCalc, we're taking your Algebra 2 stuff, dialing it up to an 11 and seeing what you got. Okay, so we did that. The type of transformation that you did not get in Algebra 2, I'm pretty sure, I know I didn't do it in mine, is absolute value. I can have an absolute value transformation, but you got to tell me, what does absolute value mean? Distance from zero. So if it is 11 miles from my house to the school, does that mean it's negative 11 miles from the school to my house? Okay. Distance can't be negative. So I use that concept here with, if I absolute value the entire function. Remember, the entire function gets me my output. My outputs are y's. I just said my y's are not allowed to be negative. So I take everything that was negative and it comes up here instead, and everything that was negative no longer exists. You take everything that was below the x-axis and flop it up. That's it. That's what absolute value of the entire function does. Now, if I absolute value just the x, I'm saying, doesn't matter what I put in for an input, I'm going to get the positive version output. So if I put in a -1, I'm not getting that. I'm getting what I got at +1. If I put in -2, I'm not getting this. I'm getting what I would have had at +2. If I put in -3, I'm not getting this. I'm getting this. So everything that was on the right is going to overtake what's on the left. Okay? Everything that was on the right overwrites what is on the left. Now, those are two different concepts. If I absolute value the whole thing, my bottom stuff comes up top. But if I absolute value just the x, I overwrite the stuff on that side. Okay?
What if your x is negative, has y negative? Would you just like
Word's bad. Try again.
what if your vertex was underneath the x?
Oh, on here?
Yeah.
Okay. So say I have, Frank, come on. So say I've got, that. Everything that's on the right overrules what was on the left, and everything that was on the left disappears.
So the y's can be negative.
Yes, because it's your inputs that are getting overruled.
That makes sense.
Okay? So, poke, poke. So, there's a graph. They even gave you an equation for it. If I want to if I want to absolute value the entire thing versus just the just the input, what does it look like? Well, suppose let's make that bigger. There we go. So if I absolute value the entire thing, all the stuff that was down here is going to come up here. The stuff that was down here is going to come up here. Everything that was below comes up top. So I get this. Looks like Aunt Judy fell over and can't get up. Okay. If I absolute value just my inputs, that means everything on the left side no longer happened. The stuff on the right side overrules it. So I get that. Okay? Absolute value of the whole thing, bottom comes up top. Absolute value just the input, right overrules left. That's it. That's what absolute value does. So, oh, that's what it is. Instead of trying to do both, just didn't have enough graph space, I would like you to do this for this guy, and I'd like you to do that for this guy here. Okay? That way you don't have to like double dip on the graphs. Just show me that you can do absolute value stuff. Hmm.
Just because you can refer back to other functions.
Mm-hmm. You know, you can do that with your table of values in your list too. Has a what?
That doesn't have the step thing.
I'm pretty sure. I have to look for it though. Pretty sure it does. I mean, it's got everything else. Y equals clear.
That is an integral. Oh, it's not.
I tried double bracket and I hunted through the catalog. I do not find step function on here.
These are still open. Because it's passing over Mystery Seller.
Oh, hold on. I'm setting reminder. So I remember to charge the calculators tonight for those who are doing ACT.
Is this the same graph? Because I feel like it's off.
You are 4 out of 5 literally missing a dot.
No. Yeah. Is it that dot?
Yeah. That's right, because the stuff on the right overruled the stuff on the left. Makes a little pyramid. Because remember, the reflection of your face when it's on the mirror is your face. So, contestant 1, if I absolute value the entire thing, then everything that was down low goes up top. That means I still have this, but now it's going to do that. Everything that was down low comes up top. Okay. The next one, all this stuff on the right gets reflected to the left. But, and it overrules this other stuff here. So this doesn't exist, this doesn't exist, this doesn't exist, this doesn't exist. Did y'all remember that dot at 0, 2? Because the reflection of something on the line of reflection is itself. That dot doesn't go anywhere. It's just the little tail with it disappeared. Okay. Well, wait. And then we did the thing, so 1/6. Said we're going to finish 1/5, move into 1/6. I think we'll have enough for example 1 and 2. Function operations. We were briefly introduced to this in Algebra 1. We hit it again in Algebra 2 with funkier stuff. And it says a function rule is an expression. So if I can add expressions, then I can also add function rules. If f is this stuff, then f plus g is literally the f plus g rules. Okay? F plus g is literally just f rule plus g rule. You got to make sure that you are putting them in the correct order, that you're simplifying wherever possible, and in this case, that just is what it is. Like, there's nothing to be done about it. That is the answer. It also asks for the domain. So we review. What are our commandments of domain? Thou shalt not. Thou shalt not. Even root of negative. Close enough, right? Thou shalt not. Log of non-positives. Do I have any of those three things in here? So you set your radical or your radicand equal to 0. And say -2 is the dividing line between positives and negatives, because if I plug it in, I get 0. Is it legal?
Yeah.
Yes. Square root of 0 is perfectly legal. So my domain is going to go from -2, that's not a 2, to infinity. Okay? If I swap that over to minus, I literally just switch it to minus, and I'll have x squared plus 4x minus square root of x plus 2, and it will also be -2 to infinity. Okay? I don't foresee a problem with those. The problem that I see happening is we just forget to distribute our negative. If this asks for f minus h, f rule this stuff. G rule. Oh, it's h now. That's why I erased and was starting over. H rule. You should have let me actually write it. Just be careful that you distribute the negative. I have so many kids, even all the way up in PreCalc, they see this on a quiz and they say x squared plus x minus 5. Okay, remember to distribute a negative 1. Okay, you are subtracting a negative 5. And if you can't remember that, then I would strongly recommend that you distribute a negative 1, write it out, then combine like terms. This one, do we have anyone who can violate one of my 3 house rules? Nope. Everybody allowed to this party. So, if I can add and subtract functions, then I can also multiply and divide functions. Okay, part C and D, same stuff, but now we're going to multiply and divide. If I say the F rule times the H rule, that's x squared plus 4x. Suppose I should do this thing again. There we go. And the H rule. When you do F times H and you use a dot in the middle like that, please be very intentional about it. Make sure that is a dot. Because what does it kind of look like? Oh, that one thing that does the thing.
Oh,
Fog and Goff. Remember compositions? Put F into G, G into F. Okay? So be very intentional about this needs to be a dot, not fog. Okay? And then clean it up. That's 3x to the third, negative 5x squared, plus 12x squared, plus 7x squared, minus 20x. Oh, and its domain. Do I see any problems about it? So, the domain. Do I have any x's on denominator? Do I have any even radicals? Do I have any logarithms? So its domain is all real numbers. Yes, ma'am. You don't have to ask, you just go. I should say that's normally my policy. My inclusion algebra has lost that privilege. So if I say h over f, here's f, here's x squared plus 4x, green, here's h, here's 3x minus 5, I have a rational function. What should I be very careful about, Carter? Whenever I see a rational function, I should be very, very careful. Not only divide by 0 for my domain, but is this even the simplified form? Okay. What if that wasn't minus 5? What if h of x was 3x plus 12? Do you see how it changes? Okay. Now, it was just minus 5, so that's not going to happen. But I have to check for it. If I don't check for it, what happens when I think, yeah, I follow along, yeah, I get it, but then I miss these little things because I'm only halfway paying attention, I get to my quiz, and my quiz ends up being a 72. You think it was a fluke. It happens again. You got a 71. It happens again. You got a 68. Oh, wait, maybe I should pay attention to this little stuff that I think I get. Just because you saw it before in Algebra 2 doesn't mean that we're not dialing it up a notch. Okay? Now, that is the end result. I need to turn this into x plus 4 to say that my domain excludes 0 and negative 4. Now we'll do that in interval notation. Negative infinity to negative 4, can't touch this. Negative 4 to 0, can't touch that. And 0 to infinity. Okay. Okay, I kind of talked about our calendar of events coming up here in about 2 weeks from today. Parent-teacher conferences. The only pre-calc parents that I see are ones who have A, unhealthy expectations and are freaking out because the kid's got a B. I got to tell them, chill out, it's fine, stop putting that unhealthy pressure on your kid. Or B, the kid who has a C or a D in pre-calc, and I've got to explain to their parents, they're flapping their lips the entire time I'm trying to explain something in class. They're back there playing Retro Bowl. They're screwing around, listening to music, doing whatever, instead of what we're actually doing in class. And then when it comes time to actually do the test, it's obvious they're going to get C's and D's. Because this ain't Algebra 2 anymore. Don't make me have that conversation with your parents. Okay? Those are the only ones I have to talk to every year. So, show me you can do it. Not your neighbor can do it, although I do want you talking to each other. I do want a collaborative effort. But you better know how to do this instead of I'm just copying my neighbor. You better know how to do this instead of I'm just going to BS for a while and then when you write it on the board, I'll copy it down. It's all Algebra 2 right now. We're just picking up where they left off. Yeah.
With this one, you can take it out.
No, you can't.
No.
That's a difference, not a product.
Oh, yeah.
If that was 9x squared, I could.
Yeah. Okay.
Okay, think about everything we've done so far, all the algebraic manipulation. All of these problems, they're just taken from the last third of your Algebra 2 assignment set. These were the challenge problems in the last class. Now they're the you better be able to do it problems. If your head is spinning with it, are you doing what you're supposed to? Are you locking it in? Are you paying attention? Are you asking questions? Or are you screwing around? That's why PreCalc gets the big bad reputation. We've never had to try before.
That's why I think I would put it somewhere. And then I just.
Oh yeah. Okay. We pick it up there tomorrow.